Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate Now that we've seen some rational expressions being simplified where the denominators are numbers, what happens if the denominators are now variables? Well, the good news is that our method can still be the same. In other words, we still want to have common denominators when we try to combine them, right? But because the variable's in the denominator, it will generate restrictions. So you need to check the denominator in the beginning and at the end for restrictions. Okay, so let's look at the first example here. I have an x and an x as my denominator. So what are my restrictions? In other words, what's a number I cannot put in that x spot? Well, when x is the denominator, I can't have 0. So my only restriction in this case is 0. So just say x cannot equal 0. Now let's actually simplify the problem. So my denominators are the same, so really I can just add whatever the numerators are. So that's my answer. Now let's check again. Did my denominator change? No, it's exactly the same as the beginning, so my restriction is still the same. So my answer is 5 over x, and then put a comma, and then say what the restriction is. And that's how I write my answer. Let's look at another one. Now in this case, the denominators are different. So remember in the previous problems, when the denominators are different, what we want to do is find a common denominator. Okay, so before we do that, let's check our restrictions. So in this denominator, I can't let x be 0. And in this denominator, even though it's squared, I still can't let x equal 0. So the good news is the restriction is exactly the same for both. Now let's move on to the next part. What's the common denominator? Well, if there's 2 x's here and only 1 there, well, we can change this one to have 2 x's, so our common denominator is going to be x squared. So the good news here is because this fraction already has x squared in the denominator, I don't have to change it. That saves me some work. All I have to do is change this one. Well, I need to multiply it by something that'll change x to x squared. Now, because we're not letting x be 0, we can write this statement. You have to be very careful. You need to state what your restrictions are. Because if we didn't state this, then essentially we would be dividing by 0 here, and that's undefined. You can't do that. Now, what does this say? This says x times 1, which is x. X times x is x squared, and then this stays the same. Now do you see the denominators are the same? Now we can add them. And that's it. Actually, there's nothing more I can do here with x plus 3. Now let's check our denominator. This denominator is exactly the same as we had up here, which had this as my restriction. So I have no new restrictions. So my answer is this expression, comma, and then my restriction. And there we go. So again, we have denominators that are different and that are variables, so they have restrictions. Let's start there. What can x not equal? Well, I have a single x and an x cubed, so the only number I can't put in there is 0. Now, let's find our common denominator. If this is x cubed, that means this has 3 x's here, and this is just a single x. I can easily change this one, this x, to look like x cubed. So let's make x cubed our LCD. Now, what do we need to multiply 7 over x by so it's x cubed? Well, if I already have 1 x there, all I need is 2 more. And again, we've declared x can't be 0, so we can write this statement, we're not dividing by 0. So let's multiply. 7 times x squared is 7x squared. X squared times x is x cubed. Now that the denominators are the same, I can rewrite this fraction. At this point, there's nothing to do. I can't combine those at all. There's nothing to factor, nothing to simplify. So this is my answer. Now let's check the restrictions. This is x cubed, which was one of my denominators up here, which had this restriction. So there's no new restrictions to consider. All right, one more. Here we go. Now I can see these are both different. So let's first find our restrictions. What can x not equal? Well, 2x, if I set this equal to 0 and I solve, I get x equals 0, so x can't be 0. And same thing happens here. So again, my restriction is x can't be 0 for both of those. So now let's find an LCD. Well, this is an x and that's an x squared. Well, we can change x to make x squared, that's easy. But there's a 2 there. So this is a 2 and this has a 1 in coefficient. So I could multiply this one by 2 to make it look like that. So in other words, my LCD can be 2x squared. So in this example, I have to actually modify both fractions. Now, my 2x is my denominator here, but I want it to be 2x squared. So on this fraction, I'm going to multiply by x over x. And again, x is not 0, so we can write this statement because we're not dividing by 0. In this one over here, I have x squared, but I want it to be 2x squared. So all I have to do in this case is multiply by 2 on both the top and the bottom equally. Now let's rewrite our new fraction. Now that the denominators are the same, I can rewrite them together as one fraction. And there's nothing else to combine or simplify, so I'm done. Now let's look at our denominator. This has a restriction of 0, but I already had restriction of 0 up here, so there's no new restrictions to add.